Hi everyone, so now in our second part of our trigonometry CSEC past paper questions, we're looking at you'll see some variation coming on, but we may have to use Pythagoras theorem later on, maybe one question or two questions, but I just want to mix it up so you could see how we use some of the other formulae as well. So in this question here, it says in triangle ABC above, AB is equal to 12 cm, AC is equal to 13 cm, and BC is equal to 5 cm. So AB 12, BC is 5, and AC is 13, right? What is the value of cos theta? So this thing here, that fancy thing there is theta. So theta, it really means that's a given angle, right? Right, theta is really the angle. So we're going to find cos of that. Now, luckily for these questions where you want to find cos and sine, some of you all say sin, it's really sine, cos and sine and tan theta, these are the formulae here we have to use. Before we get to that, let's figure out how we know what side is what. Now we learned before that the side opposite the right angle is the hypotenuse. So the side opposite the right angle is always the hypotenuse. When you are given an angle, like here you see we're given an angle, the side opposite the given angle is called the opposite side. And then the third side is the adjacent side. Right? So coming to our diagram, the side opposite the right angle is always the hypotenuse. The side opposite the given angle is called the opposite side, OPP, you could write. And then the third side is the adjacent right side. You could just write EDG. We want to find the value of cos theta. Again, this formula given in the formula sheet at the front of the paper. So looking at the formula sheet, cos theta is the adjacent side over the hypotenuse. So the adjacent side over the hypotenuse. For these questions, always label your diagram first. Always, always. We already did that. Our adjacent side is 5 and our hypotenuse is 13. So cos theta is 5 over 13, which is A. Right? All my asks, how we will know when to use these sine, cos, tan formulae. We use these when we are given an angle and then we have one other side or two other sides, right? For Pythagoras' theorem, I'm repeating it again. Pythagoras' theorem, the only angle we know for Pythagoras' theorem is that right angle triangle is always there. That right angle, that little square box, right? Other than that, we're not given an angle, right? So we look at some other questions. So you keep on seeing, okay, when we really use these different ratios, sine, cos, and tan. Now, looking at this question, the triangle ABC is right angles at C. So they're showing the right angle triangle there at C, right? Angle ABC. So you see the little kind of like, it looks like a hat. That's the angle at B there, right? 40 degrees. And AC is 20 cm. The length of BC is, we want to find this. What is this side, right? BC. So remember what I said from before? Label your triangle, right? So the side opposite the right angle is the hypotenuse. But they didn't give us any value for the hypotenuse. So we don't need to use that, right? The side opposite the given angle is 20. So this is OPP, opposite side. And then the third side, which we want to find, is the adjacent. Now, we want to find this length. Again, we have the angle, we have a given side, we want to find the third side, right? So we need to know which ratio we're going to use. So we have the opposite side, we want to find the adjacent side. You need to look and see which one of these rules formally uses opposite and adjacent. So if you look carefully, tan uses opposite and adjacent. So we'll have tan of the tan theta is equal to opposite over adjacent. My angle here is what, 40, right? So that's really tan 40 degrees is opposite is 20 over adjacent. We can leave the adjacent as BC, right? Now, I'm just going to rewrite this. 20, not 20, sorry. I don't need to rewrite anything. So we have tan 40 degrees is equal to 20 over BC. I want to find BC, right? But BC at the bottom here, I want to remove that BC from across here. So let's carry it across to the other side. If I'm dividing by BC here, when I carry it to the other side, it will become what? Tan 40 degrees multiplied by BC. And that's equal to 20. And now, BC is equal to, let's carry across this. So multiplication by tan 40 degrees become division by tan 40 degrees. And that's my answer, which is B. Again, first thing, label the side. Side opposite the right angle is hypotenuse. Side opposite the given angle is opposite side, and the third side is adjacent. They wanted us to find BC. We need to find out which one of the rules uses opposite and adjacent, which is tan. So tan equals opposite over adjacent. The given angle is 40, so let's replace your values now. So tan 40 is equal to 20 over BC, and you go ahead and you find your side, right? So now for this question, it says in the figure above, sine theta, remember I told you this is theta, that's what they use there, is equal to 4 over 5. What is the value of tan beta? That's actually, that's not a B, that's beta, right? In maths, they like to use a lot of Greek symbols. So theta and beta, right? It just represents angles, right? In this case, beta. Now, sine theta is equal to 4 over 5. Now, remember for sine, if you look at your formula here on the side, it's opposite over hypotenuse. So, if theta is here, that's our given angle. Our opposite side is here, which would be 4. And then the hypotenuse, remember, this is always the hypotenuse, this is the 5, right? And this is hypotenuse. Again, I'm going to go over that. Sine theta is, so sine theta is opposite over hypotenuse. Cool? So sine theta opposite over hypotenuse. So cool. So according to, with respect to theta, our opposite side is 4, right? And my hypotenuse is always opposite the right angle, that's 5. Cool, so we have part of our diagram labeled. So we want to find tan beta. So tan, if you look across the right hand side, is opposite over adjacent. Now remember that trick we spoke about in part 1? When you have a right angle triangles and you have 4 and you have 5 as the sides, the third side is 3, right? Don't try and learn off this for anything else, just it works for this, right? 5, 4, 3, 4, 5, right? If you didn't remember that, then you have to go ahead and use Pythagoras' theorem to find the length of this side and so on, right? But it's easy to remember. Once you see 4 and 5, third side is 3. Once you see 3 and 4, third side is 5. Once you see 3 and 5, the third side is 4, and so on, right? So right, tan beta here now is opposite over adjacent. So this is my angle now, beta. So my opposite now is the 3 is opposite over my given angle of beta. And my adjacent to be this here, the 4. So you have to be very careful because the opposite side for given angle theta is 4. But the opposite side for the given angle beta, that's the thing that's said over like a B, is 3. Right? So just be mindful of that, right? And you should be fine. Now, these two next questions, they're side to side next to each other because, again, they're similar. The answers for this one, if you forgot to put in the lines there, right? Cool. So, what is the value of cos theta for this one here, right? This is theta here. Remember, so the side opposite the given angle is opposite. Right angle triangle is here. Right angle is here, so this is the opposite side. Cool, and third side is the adjacent, right? So cos theta, remember, you can go back and look at the formula. Cos, so this is the easy way to remember as well, right? So Ka Toa. You don't need to remember this because they give you all the formula in the formula sheet. So for cos, so C represents, so S represents sine, O is opposite, H is hypotenuse. C is cos, A is adjacent over hypotenuse. T is tan, tan is opposite over adjacent, right? So we want to find for cos. So cos is the C, adjacent over hypotenuse. Again, you don't need to remember that. That is given to you in the formula sheet. So just using the numbers here now. Now again, cos is adjacent over hypotenuse. I don't have the adjacent side, but again, remember the trick I showed you. The other two sides are 5 and 4, so the side is 3. 3 over, and hypotenuse is 5. So the answer is A, right? See, very simple. Now for this one here, similar triangle they gave you. Now here they use the given angle as beta. Remember, we saw beta in the other question. On the diagram above, sine beta. What is sine again? Sine is opposite over hypotenuse. So let's label our stuff. So again, the opposite side of the given angle beta is here. This is opposite. Right angle is here. This is hypotenuse. This is adjacent. Again, it's here they didn't give it the opposite, but we know our trick. The other two sides are 4 and 5. This is 3, right? So 3 over 5 for sine beta. Right? And our answer again is A. Now you see we get the same answer, right? But you see the position, the angles differently, right? So just all you need to know is how to label the diagrams, and to know which ratio to use, right? Sine is opposite over hypotenuse, cos and tan, and all those formulae are given to you at the beginning of the formula, the paper, right? So don't ignore that formula sheet at the front, right? Use it, right? Because for some questions you already use it, So just keep that in mind. Remember, we only label these sides for right angle triangles only. No other kind of triangle. Right angle triangles only, right? So now let's look at this question here. In the right angle triangle above, which trigonometric ratio is equal to 4 over 8? So, which one is 4 over 8? So, want to know what gives us 4 over 8, right? So, what we need to do is, let's try it with, if this was, let's use the given angle as x, right? Let's forget the y now. Given angle as x, so let's say this is the opposite side, right? And this is that hypotenuse. So could we use opposite over hypotenuse? What is opposite over hypotenuse? Sine, right? So sine x. And there we have it, sine x. Sine of the given angle, opposite over hypotenuse. Look how easy that one was, right? So just to check if I had used y, right? So y, if I'd used y, then this would have been the opposite side, and this would be adjacent, and this would be hypotenuse. So 4 over 8 would be adjacent over hypotenuse, which is cos of y, but we don't even have cos of y, right? So very easy, right? Any questions you all have? If you're confused about anything, leave a comment, and I will try my very best to try and assist, right? Because I know some of these topics are very confusing for some people, and that's totally understandable. Not because us teachers, we say, yes, maths, everything easy. We know everything, maths is not easy. It's something to practice and try and learn, practice a lot. Practice is actually the key word, right? And you will get it, so don't worry. Pause, replay, and you'll be fine, right?